In this video, we're going to look at solving a basic tangent equation that involves stretches, compressions, and translations. So this says find in radians and degrees. So first we'll work in radians. And then we'll come over here and work in degrees. I'm going to write it down now so I don't forget to come back and do that. All solutions to the equation square root of 3 tan 2 theta plus 3 equals 0. So we'll start off just by rewriting the tangent function. Always rewrite the original problem. Root 3 tan twice theta plus 3 equals 0. We're going to subtract 3 from both sides. So the goal is to get the tangent function by itself. So that's going to leave us root 3 tangent 2 theta, and then we'll divide both sides by the square root of 3. So divide by the square root of 3. So that's going to give us 1 times the tangent of 2 theta. And then we can simplify this. So what we can recognize is that 3 is the same as the square root of 3 times the square root of 3. So if you were to divide both sides of this relationship by square root of 3, you would get 3. Divide both sides of that relationship by the square root of 3. I only did it on one side. Divide both sides of that relationship by the square root of 3, and you get 3 over root 3 equals the square root of 3. And if this happens to have a negative on it, we're going to have a negative on this side. So we can simplify this right here to negative square root of 3. And then to get the 2 theta out of here, we can take and apply the inverse tangent function to both sides. So the inverse tangent of the tangent of 2 theta is just 2 theta, equaling the tangent inverse of negative square root of 3. And then we want to think about this for a minute. What we want to remember is that this is the angle that generates the side ratio negative square root of 3. We ignore the left-hand side for a minute. This is the angle that generates the side ratio negative square root of 3. And what we want to recognize is on the tangent function, we've got these vertical asymptotes. And the tangent function, we know that it repeats itself over and over and over again. So if this is my x-axis, negative root 3 is going to be down here where we are intersecting these equations, and the distance between vertical asymptotes is pi radians. So the solutions repeat themselves every pi radian. So what we want to do is say plus pi k. The solutions repeat themselves every pi radians. And then we want to look at the tangent inverse of the square of negative root 3, and we want to ask the question, does that correspond to a special angle? And we want to recognize that the tangent inverse only gives us angles between negative pi over 2 and pi over 2. So we need an angle between the negative pi over 2 and pi over 2 position that's going to generate this side ratio. And so what I want to notice is that if I have an angle of 60 degrees or pi over 3 radians, it would have the ordered pair 1/2 square root of 3 over 2. And if I reflect it down into quadrant 4, I get an angle right here that's going to be negative 60 degrees or negative pi over 3 and have the ordered pair 1/2 negative square root of 3 over 2. So the tangent function, which is the ratio of y over x at negative 60 degrees, is going to be the ratio negative square root of 3 over 2 over 1/2. The 2's are both in the denominator position, so those will give us a 1. We'll get negative root 3 over 1 is just negative root 3. So negative pi over 3 radians, or negative 60 degrees, generates the side ratio negative square root of 3, and this angle has to be the angle that generates that side ratio. So I can simplify this. Twice theta equals the tangent inverse of negative root 3 is negative pi over 3 radians. See how fast I can get rid of that picture because he's going to be in my way in a minute. So he's still going to be plus pi times k, and then to get theta by itself, we simply multiply both sides by a half. So I get a half of 2 is 1, I get 1 theta equals, and then I distribute the 1/2 into the parentheses, so I distribute it into here, I get negative pi over 3 times 2 is 6, plus, this is really pi k over 1, so I get 1 times pi k is still pi k, and 2 times 1 is 2. So this gives me one part of the solution set. No, this gives me the whole solution set, but not the whole solution, because I'm supposed to find it in degrees. So for the tangent function in radians, this is all solutions. It's getting late at night and I'm starting to misspeak a lot, so this needs to be my last video for the day. Okay, so if we do the same thing in degrees, the process is going to be the same. It's going to be the same process. We would just rewrite the equation. We'd say, hey, square root of 2 tan 2 theta plus 3 needs to equal 0. We would subtract the 3 from both sides just like we did before. We would divide both sides by the square root of 3 just like we did before. We would recognize that 3 divided by root 3 simplifies to square root of 3, so we would get negative square root of 3. Root 3 divided by root 3 is 1. 1 times the tangent is just the tangent of 2 theta. We would apply the inverse to both sides, so we would get 2 thetas equals tan inverse of negative square root of 3. And then we would say, hey, the solutions, the period of the tangent function is pi radians or 180 degrees. So in degree world, we're going to repeat our solutions every plus 1. I've got myself in a pickle here. Plus every 180 degrees times k. And then we would look at the tangent inverse of negative root 3, and we would say, does that correspond to a special angle? And we already saw that it did. It corresponded to negative pi over 3 or negative 60 degrees, so we would make that replacement and go plus the 180 degrees times k, and then we would divide both sides by 2 or multiply both sides by half, which would give us theta equals negative 60 divided by 2 is negative 30 degrees plus 180 divided by 2 is 90 degrees times k, and this would be all solutions in degrees. All solutions in degrees. And over here it's all solutions in radians.